In this lesson we've got two learning outcomes. We're going to be estimating sizes, and there's two approaches to estimating sizes. We can use the microscope field of view, and we can also use scale bars. So what is a field of view? Well, quite simple really. When you look down a microscope, the field of view is everything that you are able to see. So all that is the field of view. Now it's possible to use a special transparent ruler that you put in your eyepiece objective, and with the ruler you can actually measure the size of your field of view. We'll have a look at a question on that a little bit later. Let's have a look at a field of view question. It says here that the upper drawing on the right shows some cells through a microscope. The field of view is 0.2 millimeters. Estimate, so there's the instruction, estimate the width and height of the cells, giving your answer in micrometers. Okay, so here we've got the field of view, and that field of view is 0.2 millimeters. So what we need to do is we need to convert the millimeters into micrometers. So by now you should be able to do this. So we need to multiply that by 1,000, because there's 1,000 micrometers in 1 millimeter. So multiply that by 1,000, and we should get a field of view of 200 micrometers. Let's start by having a look at the width of the cells. So here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 3/4, maybe 10. Let's say there's 10 cells lined up within that field of view. So we've got 10 cells within 200 micrometers. So clearly we want to divide that 200 into 10, and that will give us the width, at least an estimation of the width. So 200 divided by 10 is going to give us a width of 20 micrometers. So that's the width done. Let's rub this out, make some space for ourselves. So now we're going to have a look at the height. So here's the height here. So how many lengths of this plant cell can we fit in the field of view? Well, I would say we could probably, I would estimate we'd fit 2 in there. So this time you've got 200 divided by 2. So we estimate that they're 100 micrometers in length. And that's how we use field of view to estimate sizes. Pretty straightforward when you know how. So this is another type of field of view question. A special type of glass slide with a very fine scale is viewed through a microscope. So this is the measuring device that I was mentioning earlier. The image below on the left shows what is seen. Human fat cells are then observed using the same magnification shown below on the right. So this is our human fat cell, and here we've got our scale. First question, what is the diameter of the field of view? So of course the diameter is right the way across there, and you can count the different steps here. 1, 2, 3, 4, 5. So it's a graduated measure, and we've got 1 whole millimeter, 1.1, 1.2. So we've got, I estimate, 1.2 millimeters diameter. You might also say, some of you might say, well, I think it's 1.25 millimeters. So the exam board will give us a little bit of tolerance. So there's your answer there for the first one. That's the diameter. Very simple. Now let's use that to estimate the diameter of the fat cell. So here's my fat cell here. I reckon that fat cell will probably take up that much space. So I reckon it's 0.2 millimeters. 0.2 millimeters. So why don't we do a conversion just for fun? So at the moment our answer is in millimeters, but what if we were to convert that to micrometers? What would we need to do? Well, hopefully you've already realized we multiply by 1,000, so our 0.2 millimeters would be converted into 200 micrometers. Okay, one more question. This time we're going to look at scale bars. So here is our scale bar, and you've probably seen these in geography because they're used very often on maps. You obviously see that on Google Earth as well. So it helps us to estimate distance. Our question says, use the scale bar on the drawing of the cell at the top of the page, well ours is at the bottom, to estimate the length of the green subcellular structures. So here's our green subcellular structure, and what we want to do is we want to use our ruler just to measure the length of this, and then we can transfer that information onto our scale bar. So I would say, on estimate, our chloroplast probably takes up that amount of space on the scale bar, a bit over half. I'd estimate that would be a structure of 7 micrometers in length. So that's my answer. So scale bars, really easy to use. We just use them like a ruler to measure lengths. So just to recap, we've been estimating sizes, we've been using a microscope's field of view to estimate the size of our specimen, and we've also been using scale bars to estimate the size of our specimen.